MS Ramaiah University of Applied Sciences.
Hi students, let us discuss on determination of total hardness of water. Before performing, let us understand what is hard water and its root causes. Water which does not produce lather with soap easily is known as hard water. Soluble salts such as bicarbonates, chlorides and sulfates of calcium and magnesium are responsible for hardness of water. Hardness of water is a measure of the total concentration of the calcium and magnesium ions present in water. Hardness of water is of two types. The first one is the temporary hardness and the second one is permanent hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium which can be easily removed by boiling. Whereas permanent hardness is due to the presence of chlorides and sulfates of calcium and magnesium that can be removed by chemical treatment. Few of these chemical treatment methods are lime soda process, ion exchange process and reverse osmosis, etc. Sum of temporary and permanent hardness is total hardness and it is expressed in ppm of calcium carbonate equivalent. Now, let me explain to you the theory behind this titration. Ethylene diamine tetraacetic acid, which is commonly known as EDTA, forms colorless stable complexes with Ca2+ and Mg2+ ions present in water at pH 9 to 10. For this purpose, to maintain the pH of the solution, that is 9 to 10, buffer solution of NH3NH4Cl is used. Here, metal ion indicator eriochrome black tea, that is EBT, is used as an indicator. When a sample of hard water is treated with buffer solution and EBT indicator is added, it forms unstable wine red colored complexes with Ca2+ and Mg2+ present in water. When EDTA is added to solution, it replaces EBT from unstable wine red colored complex. The free EBT indicator gives blue color to the resultant solution. Procedure. Since EDTA is sparingly soluble in water, disodium salt of EDTA is used for practical purposes. Now, let us prepare the standard EDTA solution by weighing 2 gram of disodium salt of EDTA crystals and transfer it carefully into a 250 ml volumetric flask. Add ion exchange water through the funnel to ensure that all the EDTA crystals slide down into the flask. Now add 5 ml of ammonia to increase rate of dissolution of disodium salt of EDTA. Dilute with ion exchange water. Make up to the mark and mix well. Finally, calculate the molarity of EDTA and transfer it into burette. With the help of pipette, transfer 25 ml of the given hard water sample into a clean conical flask. Then add 5 ml of NH3NH4Cl buffer and a pinch of eriochrome black tea indicator. Titrate the solution in the conical flask against EDTA till the color of the solution changes from wine red to clear blue. Repeat the experiment for concordant values. Hard water sample plus buffer. Hard water sample plus buffer plus EBT. Hard water sample plus buffer plus EBT plus EDTA at the end point. Precautions. It is essential to use double distilled water during the experimentation, as tap water may contain salts of calcium and magnesium. Always handle NH3 solution carefully, as it can cause serious burns to your skin and eyes. As ammonia fumes irritate the respiratory system, don't inhale it deeply.
Hi students, today we will be learning one volumetry experiment. Aim of the experiment is to find out or determine the hardness of the given water sample. So hardness is a property of water which does not give lather towards the soap solution. So hardness can be divided as temporary hardness and permanent hardness. Temporary hardness is because of bicarbonate salts of calcium and magnesium. Permanent hardness is due to calcium, magnesium, salts of chlorides and sulfates. So here, today's experiment, we are going to find out total hardness. We are not going to differentiate whether it is temporary or permanent. We are going to determine the total hardness of the given water sample. The apparatus required to find out the hardness of water. So we need hard water. So hard water sample to find out the hardness of the given hard water sample. An indicator EBT, indicator used EBT, aerochrome black tea. So this is also a complexometric titration. Buffer solution to maintain the pH of hard water sample. Ammonia solution, ammonia 1:1 ammonia to increase the solubility of EDTA. This is EDTA. So here we are going to do find out the hardness using complexometric titration. So we are going to use EDTA. So a known quantity of EDTA has been weighed and transferred to a weighing bottle. To prepare the standard solution, we need standard flask. To prepare the standard EDTA solution, 25 ml pipette to transfer the hard water sample to the conical flask. A conical flask, 250 ml conical flask, where you are going to transfer your hard water sample and carry out the reaction. A funnel to transfer the solid EDTA to the standard flask. Test tubes to add ammonia and to add the buffer solution. We will be using the test tubes. Burette, a 50 ml burette, which are using to transfer the standard solution you are taking in the burette. Wash bottle containing distilled water to wash the apparatus. So these are the apparatus required to start this experiment. Now let us start the experiment. So before starting the experiment, you have to see that all your glass apparatus to be washed with tap water and then rinsed with the distilled water. So first I will show you how to wash the burette. So you have to wash with tap water and then rinse with distilled water. So you have to open it from both the sides. Open it from both the sides. So it has been washed with water and distilled water. Similarly, the funnel, you have to wash with tap water. 3-4 times you have to wash and then rinse with the distilled water. Rinsed with the distilled water. The funnel to be washed with tap water and then rinsed with distilled water. And then the standard flask, where you are preparing your standard EDTA solution. The cap also. thoroughly wash 2 to 3 times because standard solution is important. Wash with water and then rinse with distilled water. The funnel also should be, the burette also should be washed. So burette, you can wash it by taking some quantity of water in the beaker. Sucking it to the bulb. Okay. Make it to flow from both the ends. Yeah. Now all my glass apparatus are washed and kept. So all the glass apparatus is washed with tap water and then rinsed with the distilled water. So now we have to prepare, the first is to prepare the standard EDTA solution. To prepare the standard EDTA solution, you have to take a known quantity of EDTA, you have to take and transfer to the standard flask, cleaned, dried, so rinsed with distilled water. Add the funnel. Transfer the EDTA sample, a known quantity of EDTA sample. Okay, transfer completely the sample and dissolve it by adding some quantity of water, distilled water you have to use, and then an half test tube of, so we have made a mark, so that half test tube you have to use ammonia. Since EDTA is sparingly soluble in water, the solubility of EDTA can be increased by adding this ammonia. So approximately it's an half test tube of 1:2 ammonia. Then some more quantity of water. You can take the funnel by adding some quantity of water on the edges. Now swirl it to dissolve the EDTA sample. Swirl, don't put the stopper, you have to only swirl and try to see that the EDTA sample is dissolved. So we can see the EDTA, it has been dissolved almost. So now we can make it up to the mark using the distilled water. Make it up to the mark using distilled water. Since you are not able to control the flow of liquid, so I have just made it up to the neck. I have made it up to the neck. I just made it up to the neck, and the remaining quantity, the small quantity whatever we want, we can add it using this burette. So the burette is already washed and rinsed with distilled water. So we can take some quantity of water in this. We can add slowly from the edges. Okay. So we can see it is not up to the mark. Still, it is less. So I want few more drops of water, so I can collect it now. Okay, done. So you can see you have to add the water, the last, from the neck up to the neck you can use the wash bottle. To the mark, the last few drops should be always use the burette, so that you can correctly control. So you can see now, you can see it now, it is exactly, the lower meniscus is touching the mark. Now you have to shake it thoroughly for uniform concentration. So shaking is important to make it uniform concentration there. So you have to make the air bubble to come up, thoroughly shake it 3-4 times. You can see now it is cleared. There is no water, there is not EDTA remaining. So your standard solution is ready. So one thing you have to see, that is you should not put the stopper until you make it up to the mark. Okay, the standard solution is ready. So the standard solution should be taken inside this burette. So you are using 50 ml burette. You can remove the water. Remove the water. Now you have to rinse it with the standard solution first. Rinsing is important. Take some quantity. Take some 10 to 15 ml. 10 to 15 ml you take. Using a funnel, you have to use it always, the funnel. So then rinse it. So rinse it. So leave it from both the sides. Leave it from both the sides. Now you can fill it up and make it up to the 0. So carefully you have to see that. You have to little bit airlift it so that there should be air gap. So then you can add it. If there is no air gap, the solution will start to bump up. So take it above the 0 mark. Now you have to adjust it to 0. There is no air gap here, so that you can just leave it a little bit faster to sink faster, so that there is no air gap. Okay. Now you can see it is 0. The lower meniscus is touching 0. See, the lower meniscus is touching 0, and then there should be no air gap inside the burette. So the care should be taken. There should be no air gap in the burette. You can fix it. Okay, my standard solution is ready. So I have made it up to 0. Now I have to prepare the hard water sample. So you have to take the hard water sample inside the conical flasks, a known measurement, a known volume. So I am taking a 25 ml pipette here. So now I have to transfer, I can say I have to prepare the hard water sample. So preparation of hard water sample, the pipette should be washed with water, rinsed with distilled water, and you have to rinse with the hard water sample. So whose hardness you are going to determine. Rinsing means taking 50% of it. So you should be going up to the mark. Slowly you can see up to the mark, and then rinse it thoroughly, and then make it to fall down on only this side. So this side we should not leave the solutions. Pipette is rinsed. So transfer 25 cm cube. A known volume of hard water sample has to be transferred to the conical flask. So I am using 25 ml pipette. Okay, so I have to slowly leave it. So adjust it to the, bring it near to your conical flask, adjust it to the mark. Yeah, the lower meniscus should touch the mark. So transfer completely 25 cm cube of hard water sample to the conical flask. We can keep the hard water sample there. To take the last few drops, which will not come so easily, so you can touch it to the tip of this 1, 2, 3, it's enough, 3-4 times. So you have to maintain the pH of your hard water sample. To that I am using buffer solution. So 5 ml of buffer solution, approximately it will be half test tube. So you are using, so we are using here ammonium chloride buffer to maintain the pH around 10. Now we have to add the indicator. A pinch of indicator. A pinch of indicator. A small quantity of indicator to the flask. So you can see now you are able to get the wine red. It's the colorless, complex, colorless hard water sample as formed. Hence the hard water is containing calcium and magnesium salts of bicarbonates and also sulfates, chlorides. So that is forming, few of them are forming the complex with the indicator aerochrome black tea. So you are able to see this wine red color. So now you are going to titrate it against the standard EDTA solution. Titrate it against standard EDTA solution. Before starting the titration, you have to see it is in the 0 mark. Yes, it is in the 0 mark. So now you can start the titration. Fix your burette. So if you are a left-hander, you can hold the burette using the left hand, and the right hand you can shake it thoroughly, so you can use it for holding the conical flask and see it. So little bit, the height should be little bit more, so that you can freely lift and rotate and you can remove it out easily. So you have to adjust, so in that way. So now let me start the titration. So it is 0. So in the left hand I am holding the burette. Okay. The right hand continuously swirling it. I know what is the end point. End point should be blue in color. So I have to titrate it until I get the blue color solution. So now you can see the color is changing. The color is decreasing. So you can see it's decreasing slowly. So first trial you can do it a little bit faster, but the next trials you have to do it very carefully, slowly you have to do it, since you are knowing the end point. So you can see now you can see the blue color coming at the center, so you can swirl it fast. Oh yeah, now I am able to get the blue color. So immediately you have to see that, so it will changes from wine red color to the blue color. So after this point, so this is the end point. After this point, if you add also, the color will not change. So you have to exactly stop when it becomes wine red to blue color. That is the end point. By knowing, first you have to report, what you have to see is, see what is the amount of EDTA sample consumed. So EDTA, what is the amount of standard EDTA consumed? To see it, you have to remove it out. So make it to the eye mark and see. So now it is 16.25, so it is around 16 point. So now you can see it is almost 16.3 ml consumed. So while seeing it, you have to see it, remove it out, see to the eye mark and then place it back. So after this endpoint, whatever you add, it will be blue color solution only. So whenever it turns wine red to blue, you have to stop the titration and note on what is the amount of EDTA sample consumed. So now you have to, this is one trial, so you have to continue this for the second and third trial. So to continue this, you have to wash your conical flask thoroughly with water. And rinse with distilled water 3-4 times, because tap water will be very much hard, so distilled water is not having the hardness. So rinse it thoroughly with the distilled water 3-4 times, that your experiments are coming good. So now you can continue the second titration by taking the hot water sample, adding indicator, you will be getting the wine red, and doing, you can continue the titration. So you have to do second trial, third trial also you have to do, 3 trials you can do and take concurrent readings. So it should be the same readings, you can take it and use it for the calculation. This completes the experiment.
At MSR UAS, we spark your imagination unlike any other.